To our next video on fractions. This one's on equivalent fractions, and we're going to look at tape diagrams, tiles, and one thing that's new for fractions to us is area models. So let's go check it out. So what is an equivalent fraction? Two fractions are equivalent if they represent the exact same portion of the whole unit. So as you can see, every single one of those pictures that you see before you, the 1/2, 2/4, the 3/6, 5/10, are all representing the same amount of the one whole unit. So 5/10 is equivalent to a half. 3/6 is equivalent to a half. And there's lots of things that are equivalent to half. These are just 4 examples. So what you're seeing on the screen with this right here is what's called the standard algorithm. So this is taught of how to do it numerically, where you're realizing, oh, to turn a half into 4, I'd have to cut each one into 2. So that 1's going to get cut into 2, the 2's going to get cut into 2, and I have a total of 2/4. Well, how do we get there, right? How do we get students to go, what? What do you mean I'm cutting? So we're going to start off with a Common Core approach, which of course is tape diagrams. Okay, so if we wanted to show that 1/2 equals some other fraction, so here I chose a denominator of 8, but we could have done any even denominator. An odd denominator is not going to quite work, but here I can show that a half is equal to anything of an even denominator. So the first thing you want to do is you want to start off with 2 tape diagrams that we stack up and down. You can have a space or not have a space. It's up to you. So here I have a space, but you can have them glued right together. Okay. Now what you want to do is that whichever fraction you're given, you want to go ahead and cut both with the same thing. So here, since I'm graphing a half, I'm going to go ahead and graph a half. So this is a half. And I'm going to go ahead and cut this one into 2. Okay. Now, we can shade this right now, or we can wait till later to shade. So it's up to you if you want your students to shade this yet. For me, I typically wait to shade because that way it's easier to see what we're cutting. And that's actually the next step. So once we have both tape diagrams stacked, both cut in half, one is shaded, one is not, I want to turn this into 8ths. So that's my dilemma. Is how do I turn that one into 8ths? Okay. So what we would do is we would go ahead and cut it, and we'd have a discussion. Like, what happens if you cut this into half? Each of these into half. Oh, I get 4ths. Okay, well, what happens if I cut those in half again? Oh, I get 8. So this is the exploring part with your students of what happens when I cut this many? What happens when I cut this many? And so what's basically happened here is that we had to cut each piece into 4. So each half into 4. Okay. Once I have that now, I'm going to shade so that we're representing the same area. So you can see that we're representing the same exact area. So that 1/2 is equal to 1, 2, 3, 4 8ths. Okay. Seems simple enough. So where does it get tricky? Where it gets tricky is when students have to draw their own shape. So if you can kind of give them a head start by having tape diagrams already drawn in, that would probably be a good thing, just so that you can make sure they're equal length. Otherwise, just have them do their best. So here we're going to use this tape diagram to find the equivalent fraction of 3/4. So I already have my 3/4 shaded equals how many 12ths? So you'll notice that the second tape diagram is already cut into 4. So what I want to do now is I'm trying to figure out how many ways do I have to cut it. So if I cut each of these into 2, that gets me 8. That's not enough. What happens if I cut each of these into 3? Oh, if I cut each of those into 3, I'd have 3, 6, 9, 12. So again, this is that exploration with your students as they're figuring out how many they need to cut it into. So here we'll go 1, 2, 3, 1, 2, 3, keep going, keep going. Now, just for the sake of so you guys can not be overwhelmed by too much shading, what's going to happen is that if you think about it, all of this would be shaded purple. Okay, so this is going to match. So when I come in and shade this purple, what I'm going to get is 9 out of 12. Okay. So you can see my warning, they really need to be careful lining them up. You also can use that cool website that I showed before, the um, math learning apps, math learning center apps.org. Let's get it exact. mathlearningcenter.org/fractions. Okay, so what I'm going to do is I'm going to show you how nice this can be as an option, as a tool with your students. So what I'm going to have down here, first thing I'm going to do is I'm going to grab a tape diagram. So if I'm going to do 3/4 into 12ths, what I'm going to do is I'm going to go ahead and just cut this one into 4, hit OK, okay. Before I go draw the next one, I'm going to put this little fraction tab out front. So that way we know we have 0/4. Okay. Now I'm going to build a second one. I'm going to attach it, and we're going to do 12ths. Okay. Now again, the nice part about this is that everything's exact, everything's beautiful, everything's pretty. So what I'm going to do is I'm going to come over here, and I'm going to color in 3/4. And then you're going to color in how many 12ths that's going to be. Now, as much as I do love this, and I do love this, I do think there is value with having students cut it themselves because it's that idea of, ooh, do I cut it in each one into 2? Do I cut each one into 3? Do I cut each one into 4? So if you're going to use this, I'd probably still have that discussion of each 4th block. How many did that turn into when I turned it into 12ths? So we can see that each one is going to turn into 3. In fact, we could uncolor some of these so that way it's easier to see. So I'm saying you can definitely use this, but have that discussion of how many cuts it takes. Now, the really cool part about this is that number one, we can do as many, we can have it cut into as many pieces as we want. So if I wanted to do 16, I could come over here. And again, we could color it, same color or different, that to turn a 4th into 16, you'd have to cut each of those cubes into 4. Okay, that discussion part is important because it leads to that standard algorithm of to change 1/4 into 12ths, I would have to multiply the top and bottom of that fraction by 3. If I have to cut each one into 4, then to change a 1/4 into 16ths, I have to multiply the top and bottom, the numerator and the denominator, by 4. So it's that standard algorithm idea. We're just setting the basis for it. Okay. All right, awesome. It's kind of fun. All right, so next thing we're going to do is we're going to talk about a different method, which are area models. All right, so an area model for fractions is basically kind of like a thick rectangle or almost square-like. The reason why you want it kind of wide is because we're going to cut it in 2 directions, okay? So what we're going to do is we start off with our first fraction, and typically when you draw the first fraction, what you're going to do is you cut it vertically. So although it looks weird to cut it vertically, if I wanted to represent 1/4, I'm going to cut this vertically into 4 equal parts and shade any one of the 4. Doesn't have to be the far left. It could be the second one, the third. So your students could be as wild as they want to be. But here I just want to shade one of the 4. And then what's kind of beautiful about area models is that I don't have to build a second tape diagram, especially if we're drawing it by hand. Make sure it's exact, all that kind of stuff. Instead, what we're going to do is we're going to slice across. So here we're going to cut across the middle to make 2 rows. So if I slice it across to make 2 rows, what we're going to have our students do is now count. I have a total of 8 pieces, and the number that are shaded are 2 of the 8. So here, 1/4 is the same thing as 2/8. So the magic of area models, why I like them so much, is that we start with the original fraction vertically, and then we either slice it once across, twice across, 3 times across, whatever, to get our next fraction, okay? All right, so let's go ahead and see how this works. So here I have 1/5 And I want to know what the equivalent fraction is in tenths. So I'm not using tape diagrams. So what we would ask our students is what happens if we cut it across once? Well, if I cut it across once, have them count. I have a row of 5 and a row of 5. So I have a total of 10. Awesome. That's what I wanted. Okay. We wanted a denominator of 15, then we'd probably have to cut it twice. Okay, so again, this idea of do I cut it once? Do I cut it twice? How many times am I doing it? But here I have a total of 10 pieces and 2 of the 10 are shaded. So this one is really nice because we're just counting. Now we did 3/4 equals 9/12 just a few minutes ago with the tape diagrams. So let's see what happens here. So here I have my area model. I have 3/4. If I cut it once, I'd get 8. So we need to cut it twice. So we're going to attempt to cut it about a third of the way and a third of the way because we want them to be in equal pieces. Okay, we count, we get a total of 12. So that's the denominator I wanted. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Awesome. All right, now I'm going to go ahead and make up one more, and I'm going to just make it up on the fly. So let's say that we wanted to do an example of, all right, let's do maybe 2/5. And I want to know how many 15ths that's going to be. So what I really like about this method is that I just have to draw a wide rectangle. And I'm going to slice it in 5. Okay, we're going to do our best to make it in 5 equal parts. Not awful. Okay. Okay. And I'm going to shade 2. So I'm going to kind of do this kind of shading just so that you guys can see space in between. So that way you guys can see the original 2 cuts. Okay. So I don't want to do it solid just so that you guys can see where those original 2 of the 5 bars are. So there's my 2/5. Okay. Now we're going to go ahead and we're going to cut this now into 15. So if I cut once across, we're going to get 10. So I'm going to cut it twice. But what I'm going to do is I'm going to actually draw my line a little bit extra just so that we can see it since I'm not using a different color. Now I could use a different color, but maybe your students are just using a pencil. So that's going to kind of really highlight that, hey, I've cut across twice. Okay, so I should have a row of 5, another row of 5, another row of 5 for my 15. And if I count, I have 1, 2, 3, 4, 5, 6. 6 out of 15. I really love these area models. They're going to really come back to us when we get to adding fractions and also multiplying fractions. So you could tell I dig it. Hopefully you do too. If you prefer tape diagrams, great. If you prefer the standard algorithm, that's awesome as well. Okay, so the point of this, just to remind you guys, is Common Core setting the why, but students are still going to learn those pieces. So for example, oops, 2/5. We've had the discussion of, okay, so this area model, how many rows did I get? 1, 2, 3. So that would be the same thing as multiplying top and bottom by 3. So they are going to transition from the visual to the standard arithmetic algorithm, but this is just giving them the, oh, that's why I do it. Those aha moments. And those are precious and good and amazing. We want to keep those. Okay. Okay. So last thoughts. I've already mentioned this, but just want to mention it one more time. If they're drawing their own tape diagrams to show equivalent fractions, they need to be extra careful when lining them up. So I'm not saying be super exact, but have them take the time to make the effort. You may want to create a worksheet where you already have 2 tape diagrams already stacked. They just have to cut them so that way the outside of them are ready to go. Okay. You can use fraction tiles. You can use area models. And yes, they still are going to learn the standard algorithm. We're just visualizing it first. So it's all still there. All right, that's it for today's lesson on equivalent fractions. Just around the corner will be a video on the relationship between decimals and fractions, and then we're going to go ahead and jump into the deep end and do adding, subtracting, multiplying, and dividing. So until then, have a wonderful time playing with math, getting your students hopefully enjoying it, and keep learning, keep trying, and don't give up. Until next time, have a great day.